All right, this is going to be the first video for Note 74. We're talking about ranges and inverses. So if we take a look at problem number 1 here, we have a function that has a stack of ordered pairs here. And what I want you to find is the domain and range. So I'm going to be very simple. I'm going to go D for domain and eventually, here we go, R for range. That way we know which one's which. So here's the plan. D, domain, let's talk about the X values. So in my ordered pairs, I have the number 0, 3, -4, and 6. Those are my X values. So those are going to be what I list out. So to list these out for the domain, I'm going to do a little set notation, so a little brace there. I am going to put the numbers in numeric order. So -4, let's see, 0, 3, and then 6. There are my X values. So that's my domain. Then the range, those are my function values, my Y values. So if I look back at my ordered pairs here, let me go ahead and get rid of those circles for the X's. If I look back at my ordered pairs, my Y values are 2, let me change color, 2, 5, -2, and 9. So again, to write out the range, I'm going to go ahead and list them out, list out those Y values. We'll set notation here. Again, ordered pair, not ordered pair, but numeric order here. So -2 is first, then let's say 2, 5, and 9. All right, so that's the answer for problem number 1 there for domain and range. All right, so then question number 2, part A, says to find the inverse of the function from problem number 1. So the function here, well, here's our function. It's the set of ordered pairs. So how do you find an inverse? Well, you invert the X and the Y's. So the function, the inverse function, this little notation here with a little -1, that means we're talking about an inverse here. So the inverse of F is going to be a set of ordered pairs. And I'm going to take each of these ordered pairs and I'm going to swap the X and the Y's. So 0, 2 in the original becomes the ordered pair 2, 0. And then the 0.35, swap that around, that's going to become 5, 3. So we swap the X and the Y. Same thing, the original point was -4, -2, so -2, -4. Let's see, 6, 9 becomes 9, 6. And finish it out, put a little brace there. That is your inverse. I wrote that huge. That should not be a problem then. So then for part B of number 2, I want to find the domain and range of the inverse. So now I'm looking at the domain and range of this function, the inverse function. All right, so let's see, domain here. And of course, range here, D for domain, R for range. This way it's very clear which one's which, all right? So if I look at my function, right, for my domain, I want to grab the X value. So 2, 5, -2, 9. And of course, I want to write those in numeric order. So -2, 2, 5, and 9. Close that one off. And then for the range, I'm going to look at those ordered pairs and grab the Y values. So 0, 3, -4, and 6. And of course, I'm going to write those in numeric order. So -4, 0, 3, and 6. And that's your domain and your range for the inverse. Now, there is a method to the madness and a reason I colored the way I colored. So I want you to look at, I'm kind of zoom in here, the domain for the original function. And then I want you to take a look at what I wrote down for the range of the inverse. Now, not only are they color-coded, they're the exact same things. All right, so because we swapped the X and the Y's, your domain and your range become swapped. So the X's that were part of your domain become the Y's that are part of your range for the inverse. And same thing, the range of the function is the domain of the inverse. All right, and that's going to be a huge deal when we're looking to find domain and range for functions where maybe we can't explicitly write out ordered pairs like this. All right. All right, I'm going to keep going and we're going to take a look at problem number 3. So let me go ahead and slide on up. So problem number 3 says to find the inverses of those functions. So for each one of these, I'm going to make a little note off to the side. We're going to do 2 things. So step 1, we are going to swap x and y. All right, so wherever you have an x in the function, you're going to replace it with y. And of course, wherever you have a y in the function, you're going to replace it with x. And then the second part to this is you are going to resolve for y. All right, so all of our functions when we start have this function notation, right? F of x, g of x. And so we're going to resolve these so that y, which is what the f of x stands for, or what g of x stands for, is back to the beginning. All right, so if we take a look at part A here, we're going to swap x and y. So clearly I have an x here. Well, where's y? F of x is the notation that we use in place of y. So if you want to, I do this all the time, I'll just write the letter y right over the function notation. All right, so where I have a y, I'm going to replace it with x. Where I have an x, I'm going to replace it with y. And then I need to solve this for y to get by itself. So right now it's y divided by 2, so let's go ahead and multiply by 2 on each side. So 2x is equal to y. Now to give it inverse notation, we're going to take the original function notation here, f of x, and it becomes f inverse of x, and that is 2x. All right, so the original function was x over 2, and the new function is 2x. All right, so that's part A. I'm going to go ahead and slide that on over. We'll take a look at part B, which is g of x is equal to 5x. So same thing, we're going to start with find the y, and take y, replace it with x. Take x, replace it with y, and I want to now solve for y. So I need to get rid of this 5. So I'm going to go ahead and divide both sides by 5. All right, so y is equal to, oops, sorry about that. Y is equal to x over 5. Again, the inverse notation here, the original function was g of x, so g inverse of x is going to be, oops, there's the equal sign, x over 5. All right, so the original function was 5x, and the inverse function is x over 5. All right, keep sliding on over, so, whoops, there we go. Trying to change color and it would not let me. All right, here, so for part C, we've got f of x is equal to x plus 8. Again, same thing I've been doing. Take y, replace it with x. Take x, replace it with y. So f of x equals x plus 8 is going to become x equals y plus 8. So to solve for y, I'm going to subtract 8 from both sides. So x minus 8 is equal to y. So to change it into function notation, so inverse of f of x, or f inverse of x is equal to x minus 8. There's our inverse function. We solve for y. And we got one more to do, and then I'm going to go ahead and call this video and do a different one for the second half of this note sheet. So here we've got h of x is equal to x minus 2. Make that my, and when I write y here, I'm kind of purposely writing it over the whole function. So it's not thinking it's like h of y or anything like that. This whole side of the equation is the y value. All right, so where we have y, we're going to replace it with x. Where we've got x, we replace it with y. So y minus 2, we're going to add 2 to both sides. So x plus 2 is equal to y. And again, the function notation here is h inverse of x. We're going to go ahead and say that it's equal to x plus 2. So if you look at our original function here, we had x minus 2, it becomes x plus 2. The function here, x plus 8, becomes x minus 8. So just like we talk about inverses when we're doing these functions, we can also talk about the inverses that we have to use to solve for y. And so when we have x plus 8, the inverse is going to also have the inverse operation. All right, so a little bit of work on inverses here, a little bit of work on domain and range at the top. All right, there is the top to bottom on the first half. I will go ahead and make a separate video for the bottom half. As always, let me know if you have any questions or concerns, and I'll see you in the next one.